Let us discuss energy and its types. I think in your early classes, you might have studied the definition of energy. In almost all books, it is given that energy can be written as ability to do work. As we already studied, work is the amount of energy which is transferred, and work can be done whenever a force produces some displacement. Just to do work, we need some energy. If there is no energy, work cannot be done. Or more precisely, if there is no energy, force cannot be applied which can produce work. So energy, you can also simply call it is required to develop a force. Any object which is producing a force on any other object, it must have some energy. Because by energy, force is produced, and whenever the force produces some displacement, energy is transferred, and we say work is done. So you must be very clear with the concept of force, work and energy. If we talk about types of energies, in general, energies can be classified in two ways. There are two ways in which energies can be classified. These are, the first one is kinetic energy, about which I think all of you are familiar. It is due to motion in a body. By virtue of motion in a body, and kinetic energy of a body can be written as half mv square. In your junior classes, all of you have studied about kinetic energy very well. The second one is potential energy. About this also you might have some idea, but in detail about potential energy we'll study in this chapter also. And right now you can just keep in mind potential energy is a stored form of energy. Energy which is stored somewhere which can be used in doing work. A stored form of energy which can be used in doing work, which produces some force, and when force produces some displacement, work is said to be done. So potential energy, right now you can just keep in mind it as a stored form of energy. Potential energy can also be of various types, but when we talk about kinetic energy, it is defined as half mv square. It is due to the motion in a body. We'll discuss about these energies in detail in upcoming parts of this chapter. Let us see one more category of energy, that is dissipated energy. We know well, when some work is done, you can simply state work done implies transfer of energy. When energy is transferred from one body to another, this energy can be either used in form of kinetic energy, or this energy can be stored in form of potential energy. And it might be possible when some work is done, energy transfer takes place, but the amount of energy which is being transferred, it is neither being used in form of kinetic energy nor it is stored in form of potential energy. That energy, it may be possible that it is lost to surrounding in form of heat, sound, etc., or some other sort of energies which are once lost can never be retrieved back. This particular type of energy we give a separate name, this dissipated energy. And always remember, whenever energy is dissipated, it cannot be retrieved back to the system. The system from which it is lost, it cannot be retrieved back to the system. This energy we call dissipated energy. We just take up a very simple example to understand dissipation of energy. That is, say if there is a rough ground and on this rough ground the friction coefficient is mu, and say a body of mass m is placed on it, we apply a force on this body to displace it. We know very well that if friction coefficient between body and ground is mu, it will experience a friction force that is mu n, and on the horizontal plane the normal reaction will be equals to mg. So the friction acting on the body here will be mu mg. Say if it is displaced by a distance s, and say body reaches a new position where still the forces are acting. In the process of displacing the body by a distance s, if we just calculate the work done by friction, we can simply state work done by friction. As we can see, friction is acting in the direction opposite to the displacement. Certainly it will do negative work. So work can be written as minus mu mg into s. Negative work implies the friction is extracting energy from the body, or indirectly this force is doing positive work and friction is extracting energy from it, and this energy which is being supplied to friction is lost to surrounding, which will not be recovered back. It is lost in form of heat which is developed and distributed between body and ground. Certainly it cannot be retrieved back for any sort of work or any sort of mechanical process. So we can simply state the energy which is lost to surrounding, or the negative work done by the friction which is gaining energy, is called dissipated energy.